Hello class, and here we are, and this is start of Unit 3. So if you'd like to keep a binder margin or a separation in your notes, this is Unit 3 that we're starting today, and it's quadratic functions. Today we're going to try, and from now on I'm going to try to do my lessons as I fill it in. It was recommended that students want to see where some of these solutions are coming from, so I thought I would try it. What results in this, folks, is a little longer video, but hopefully you can have a better understanding of how I've written down my answers, okay? And again, always please come and see me if you need help or clarification. All right, let's get started. Warm-ups 3.0. Number 1, identify 3 forms of the quadratic functions and state their important information. So this is a review of grade 10. The first one we'll take a look at is standard form. Okay, and standard form is f at x, or used to be y, equals ax squared plus bx plus c. And again, the important piece of information given in this form is that the c equals the y-intercept. So when we had word problems in grade 10 and we had it in standard form, we were looking at a rocket question, the c, or the constant value, would give you the initial height of the rocket. Or think about kicking a soccer ball or teeing off a golf tee. The initial height of that ball when it was hit, or the golf ball when it was swung or hit at, is going to be your c value. Okay? The next, probably the most familiar one, is probably your vertex form. Now I know in grade 10 they used P and Q. Okay, in our textbook they're going to use what's called H and K. So f at x equals a bracket x minus h squared plus k. And what the important information given here is that the vertex is h and k. Just remember for the h that the negative is part of the, if you look here guys, the negative is part of the formula, so k is going to be positive itself. Also make special note here that when we did transformations, instead of using h and k, sometimes we were talking about d and c. So the vertex can also be d and c. And we'll be getting into that in a couple lessons. The third type of form that you might see a quadratic in is called factored form. Okay? And factored form is where you've actually taken the expression maybe in standard form and you factored it. So it looks like a times x minus s times x minus t. And the important thing here is that you're given your factored form, so s and t are your x-intercepts. Okay? Just make sure you're aware that x-intercepts also mean some other terms that we did in grade 10. They also mean the roots. They also mean the zeros. And finally, guys, they also mean your solutions. Okay? So it's good thing that we reviewed factoring in our last unit to get us to be able to use that form a little more efficiently. All right, question 2 in the warm-up says to use the quadratic formula to solve below. Just keep in mind, folks, that I will not expect you to know the formula, but you need to know how to use it. So the quadratic formula, you should recognize it when I write it down, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so what we're going to do is substitute values in for a, b, and c and to solve. Okay, someone in my class said, hey, Mrs. R, this looks, for a, it looks easier to factor. Can we just factor? You could if it just said to find the roots or find the x-intercepts, but in this case, the question actually asked you to use the quadratic formula. All right, so what we need to do is say, hey, a equals what value? It's what is in front of x squared. That's 1. B is our middle term, which doesn't exist, so b equals 0, and c equals negative 16. Subbing it in, we've got x equals 0, okay, plus or minus the square root of 0 squared, which is just going to be 0, which is going to be minus 4 times a times c, all divided by 2 times a. Okay, let's simplify this through. So we've got plus or minus under the square root. If you use your calculator, you'll get 64 divided by 2. Simplifying more. Okay, square root of 64 is 8 divided by 2. Keep simplifying here, guys. 8 divided by 2 is 4. Okay, so x can equal 4.0 or x can equal negative 4.0. If we were to graph that, ladies and gentlemen, we would notice that at negative 4 and at 4, that's where our graph hit. And looking at the direction of opening, our parabola is up. So it's going to look like this. Again, two answers means two solutions or two zeros. All right. Taking a look at the second example, ladies and gentlemen, B. Okay. Before I approach this question, just think back to last unit when we factored. We always want to make the question easier if we can. So looking at this example, guys, we're going to notice that we can factor out a 3. Okay, so this equals 3 times 3x squared minus 2x minus 5. Okay. In the past, in order to use the quadratic formula, you let y equal 0 because you're finding your x-intercepts. So if you're wanting clarification on that, you can divide both sides by 3. So then you're left with 3x squared minus 2x minus 5. Okay, so again, you divide both sides by 3. And then we can simply go and find our a, b, and c values. So a equals 3. B equals negative 2, and C equals negative 5. Subbing it in, you've got x equals negative b, so negative times negative makes a positive, plus or minus the square root of negative 2 squared minus 4 times 3 times negative 5. And that's all divided by 2 times a, which is 3. Okay, let's simplify that some more. We've got 2 plus or minus, and just use your graphing or just use your calculator and get the total there. You'll find it's 64 divided by 2 times 3, which is 6. Again, we can simplify this more. So we are going to have 2 plus or minus 8 divided by 6. Now looking at this, folks, we can still simplify this expression, i.e. look at every term. Every term can be divided by 2. So 2 goes into 6 3 times, 2 goes into 2 1, and 2 goes into 8 4 times. So what are we left with? 1 plus or minus 4 divided by 3. Then this is where we break it into our two cases. So either x equals 1 plus 4 divided by 3, or x equals 1 minus 4 divided by 3. Use your calculators, okay? And we'll take a look here. X equals, let me pause it for a second. Sorry, we're back there. I forgot to put my answers down, so I had to grab a calculator. Apologize for that. So we're solving here, guys, our roots. So 1 plus 4 is 5 over 3. However, it says to round to 1 decimal place, so that's going to be x equals approximately 1.7. Okay, looking at our second root, x equals negative 3 over 3, which equals negative 1 decimal 0 because it asks you to round to 1 decimal place. Again, let's just quickly review, ladies and gentlemen. You can have two roots, one root, or no root. Let's just quickly take a quick moment to do that. Here is an example where you have two roots, where you're going to have two solutions. So either your vertex is below the x-axis and it opens up, or you could have it, the vertex starting down or starting above the x-axis and opening down. Two roots is that solution. If you were asked to have one root, that's kind of a tricky one. One root means that it has to have the vertex on the x-axis. So the direction of opening can either be up or it can be down. And lastly, ladies and gentlemen, if you have no root, okay, a no root. Sorry, I don't know what happened there. Uh-oh, let's see what's happening here. Okay, let's try that again. No root, ladies and gentlemen, is where the parabola has a vertex above and it opens up, or it has a vertex below and opens down. No root's going to be easy to recognize when you're using the quadratic formula because it's where you have that negative square root. So hopefully you remember that from grade 10, that if you had a negative square root, that means there's no solution. All right, so that's just a quick warm up. Let's get into today's lesson, which is just some information about your parent function. Most of this is from grade 10, with the exception of some domain and range stuff that was this year. All right, so again, the title is 3.1, Getting Started. Let's just recall, folks, that the parent function for a quadratic function is f at x equals x squared. Okay, a little bit of a parabola review. Okay, so parabola is v, vertex, h and k. And don't forget, you could also use D or C if you're doing the transformations. And just remember that each of those has a specific thing. So the first, the H, which is the first ordered, or the X ordered pair of your vertex, that is the axis of symmetry. So axis of sim. Okay? Whereas your K value or your C value, that is your optimal or min-max value. So some of you know it as min-max, but it's called optimal value. Okay? So that ordered pair comprises those two things. Next, we'll take a look at the direction of opening. To do that, you need to look at A. And A is easily recognized in any form of the quadratic. It's always what's out front. Okay? If A is positive, it opens up. Here's my short form from positive, PVE. So positive A, it opens up. And if it's a negative A, it opens down. So negative A. All right. Axis of symmetry, again, we covered it here. It's related to your H or your D. So you can write down, if it's given in vertex form, you would say X equals H. Or if you're talking about transformations, X equals D. And that's when you're given a vertex form. However, if you're given factored form, remember there's a short formula here, and it's X equals S plus T divided by 2. Makes sense, guys, because remember your axis of symmetry has to be halfway between your symmetrical points, and any of your x-intercepts or your zeros have to be symmetrical about the vertex. Okay? And for your min-max values, again, you're going to look at K, which is the ordered pair K, folks, or C. Okay? So it's a second, it's your Y value or your second part of your vertex. Okay? And basically, if it's positive, it opens up. And if it's negative, if it's positive, it opens up and you have a minimum. Okay? And the minimum value, I apologize, let me start that over again. If A is positive, it opens up, which means you have a minimum value. So that means the minimum value is right here. If A is negative, it opens down, which means you have a maximum. And maximum amount occurs at your K or D value. All right. Roots. Ladies and gentlemen, remember there's a couple other names for roots. They can be your x-intercepts. They can be your solutions. Okay. And they could also be your zeros. Okay. If it's in factored form, it's easy to see that it's your S and T. If it's not in factored form, then you're going to have to factor your expression from standard or vertex to get that value. Okay? So for your domain and range, for quadratics, just remember your domain is such that x belongs to a set of real numbers. That's from Unit 1. Whereas the range does have a restriction. So the range has a restriction and it's based on your optimal min-max value. So I'm going to say such that y is less than or equal to c, and that's when you have a maximum. So it opens down, which means if you have a maximum, you have a negative a. So that's that case. Or It's going to be greater than or equal to C, given that this is a minimum or a positive A. So again, that restriction is based upon direction of opening and your optimal value, which is your y value of your coordinate. All right, last part of the note is on switching forms. Okay, to switch forms, some of these are going to be easier since we've done Unit 2, and some of them I think will still be a struggle. But let's take a look at switching forms for A. If we're going from standard form to factored form, what are we going to do? Again, factored form means you need to factor, and hopefully after Unit 2 you're much better with that. What if we're going from factored form to standard form? Go to the opposite of factoring, which is to expand. And again, hopefully you're more comfortable with that. Standard form to vertex form. This is where we still have trouble, and we're going to be covering it in the next couple days. That's called complete the square. I know people still struggled with that on their first unit test, so we're going to go back to that and take a look at that. And the last one, ladies and gentlemen, vertex form to standard form. Again, you need to expand. All right, so here ends lesson 3.0. Your homework today, folks, is page 138, numbers 1 to 7. Good luck with that, and see me if you need any help. Have a great day.